Question number 3 says that Dave rides his bike 40 kilometers and runs 10 kilometers in a duathlon. He runs 20 kilometers an hour slower than he rides, and his total time is 2 hours and 20 minutes. What's his riding speed? So first of all, I'm just going to state my variable. I'm going to let x equal riding speed. Okay, so we need to use a property that the distance is equal to velocity times time. Okay, and then we need to come up with an expression for what we have here. So it says his total time is 2 hours and 20 minutes. So I need to come up with an equation for total time. But I also need to make sure that that total time is not in hours and minutes, but either all hours or all minutes. So total time, first of all, I'm going to convert that to hours. So that's 2 1/3 hours, or 7/3. 7/3 hours. Okay, so that's the first thing. You can use decimals if you like, but decimals are going to be awkward. So that's our first thing. And then secondly, I'm going to come up with an equation for total time. So my total time is going to be equal to time on the bike plus time for run. And so my total time of 7/3 hours should be the distance on the bike, so that's 40 kilometers, over the velocity for bike. In this case, we've already established that that's our riding speed. So over x plus the distance for the run. The run distance is 10 kilometers. And then the velocity or speed for the bike is going to be, run, is 20 kilometers slower than the bike. So I'm going to use the bike speed as my benchmark, and then I'm going to slow it down by 20 kilometers. 20 kilometers per hour. So once I've established that, there is my equation. So I have to first of all identify what my unknown is. I have to figure out what is the equation in this. So what am I equaling? So in this case, I'm going to equal total time. I need to find out the expression that's going to give me the total time based on the distance time velocity relationship. And then I need to write the equation. Once I've done that, now I can solve this, and I can solve this as a quadratic equation. So I want to get rid of the denominators first. So I want to get rid of the divide 3, divide x, divide by x minus 20. So I need to multiply by all those terms. So when I do that, I get 7. Actually, I should state a restriction. X cannot be equal to 0 or 20. Okay, because I'll end up dividing by 0. So those are some restrictions I should observe. So when I multiply this out, the 3's cancel out. I get times x minus 20. When I go to the 40, I'm going to have the x's cancel out. So I'm going to end up with times 3 times x minus 20. And for the 10, the x minus 20's cancel out, so I end up with times 3 times x. So there's my equation, and I'm going to end up with a quadratic equation. 7x squared minus, be careful, you have to multiply by 7 and x, so I get 140x equals, I get 40 times 3 is 120, so I get 120x. 120 times 20 is 2,400 plus 30x. Okay, so there's my quadratic equation. I'm going to make that all equal to 0. So I'm going to subtract 150x, so that's going to be minus 290x plus 2,400 when I add 2,400 to both sides, and that's equal to 0. So this looks like it would be awkward to factor, so I suspect it's probably factorable, but I'm just going to plug it into the quadratic formula. So I end up with 290 plus minus the 290 squared. So I'm going to square 290. I get 84100 minus 4 times A times C, and that's all over 2A, which is 14. Okay, so then I get 4 times 7 times 2400. That's going to give me 67,200. So when I subtract that, I end up with 290 plus minus the square root of 84,100 minus 67,200. I get 1,600, or sorry, 16,900. And that's all over 14. 1,600 or 16,900 is a perfect square of 130. So I end up with 290 plus minus 130 all divided by 14. So that's going to be 420 divided by 14, which is 30 kilometers an hour. And 290 minus 130 is going to give me, that will give me 160 divided by 14. So that's going to be 8 over 7 kilometers per hour. So that's far too slow. We're going to eliminate that. So the answer we're going to end up with is 30 kilometers an hour is going to be the riding speed that we're looking for. Okay, so we'll use that one as our solution, 30 kilometers an hour.